Welcome, I'm Bill Wake. We're here working on a programming language called Tenth. It's a subset of Fourth, and lately we've been working on the compiler. We've got the basic compiler done, but we're going to add to it by adding the ability to compile numbers. And numbers, they become, well, they're constants, but they turn into the expression push and then the constant. So our list of secondaries will need a call to push followed by the number that we want to, the actually constant we want to push. All right, I just ran tests and everything's still looking good, so I think we're in good shape that way. Well, I think we'll move that one down and do this one first. All right, so let's see, is that core? Yeah, okay, so oh, it's going to be in repl. We've got the core that creates the header. That's going to be fine, but not interpreter, repl. The repl has our compile function. Okay, so when you compile, normally you've got a word like add or sub or multiply or if or whatever. Those words just get looked up in the dictionary, and then the pointer to their code basically gets added to the list of the secondary. But what we do now is if you look for the word that they gave you, and if it's not found, we just call an error message. We call the global word not found handler. And it prints a message, and we go on. But in this case, the word isn't found because it's not a normal word. It's a number. You know, if it's 1, 2, 3, 7, 8, we're not going to have that in the dictionary. We do have 1 in there, just the number 1, and we probably should have the number 0 in there, just as they're both common enough. It might be worth the extra cutting out a little extra work somewhere. But so anyway, we need to change this so we detect if the word was not found. Well, is it all numeric? Because if it's all numeric, then we want to do this push in thing. All right, now I kind of ran in late from lunch, so let me I don't have my monitor here to see any comments coming in. All right, there we go. Yeah, Mudshark. You can't add a number 0. Yeah, right now yeah, so our routine that looks up numbers only recognizes positive numbers. And yeah, so that'll definitely mean we have to have a 0 word somehow. I can make somebody type some number neg and get negative whatever, but yeah, I'm not going to make them do, enter 1, 1, subtract. Now I have a 0. Okay. We did something like this already. So eval, we're going to kind of adopt the same structure. So it looks for known words. If it doesn't find a word, it checks for a number. And if it finds a number, if it's all positive, it just pushes that number right then and there on the stack. Okay, because it's in evaluate or execute mode. And if it doesn't find a number, then it must have been an unknown word. Okay, for us in compile, we only have one of those 2 clauses. So let's make the test for it. I've got repl tests here. Eval. Let's find some stuff on compile. I guess we can, I'll put it above it since we're there. BL compile pushes number or emits push when number found. Okay. And we'll define that routine down towards the bottom. Error handler. Okay, let's go after that. All right, test start. Test end. Whoops. Now, are we, yeah. Okay, so I don't think we need to put anything in the dictionary for this. In our secondary space, we got 10 words to fill. Yeah, we can use this. I guess I'll take both these lines. All right, and then somewhere here we're going to act, and then somewhere we're going to assert. Okay, so we'll push this, we load the word to find. Well, I guess we'll make another. Go with the classics. Okay. That's number to find. X0 is L number, or number to find. Okay. And then somewhere we're going to branch to the compiler. That's pretty much the same. I don't know if we need more setup than that. Okay. And then, well, what have we done here? Dictionary search, X1, X0. Okay, so I guess we're really, what, X0? Right. So we're kind of assuming the header was already written. We don't really need to test that part. So we're just going to look at that compile test space is where we're writing stuff out. So we should see at compile test space, we should see push. Now, how we get to push, that's going to be a little tricky, but let's see. So I guess if we load address X0 is L compile test space, that's where that secondary space, we should see, well, I'm going to skip forward one because that one's more the one I know what to do, a little easier. I guess if I load it again, and then I can load X1 equals 42 and assert equals. So the second word, whoops, X0 equals X0 plus 8. So I'm going to look at the second word after compile test space. That should be the contents. Oh, I got to load that again, right? No. Yeah, got to load again. Okay, so I have a pointer to the word I want to load, but I have to load the word. Load register X0 contents of X0. Okay. So that line should be right. The contents of the second cell should be the number that we tried to push. And then the contents of the first cell, X0 contents of X0, and we're going to assert equals, but we got to figure out X1. Now, X1, I think push is maybe in core here. Yeah, push. Okay. Colon, semicolon, push. 1. Push. Oh, interesting. We need a cell that points to this. So because of the way we represent our secondary words, they point to a pointer to the code you want to run for primaries, and this is going to be a primary. So let me find one of our pictures. Well, that one doesn't actually help. Yeah. Well, maybe I don't have a good picture. Well, I kind of say it. I mean, I'm pointing address of code. This cell contains the address of the code to execute. So I guess, yeah, that is the... No, is that right? No, this has to be an address that points to the code. I don't know if I don't think push is not an official word. So if I get main up here, I think the answer is we don't have this address yet, right? So notice push is not on this list because you don't directly call push. You just create the number and that value gets called. And so it's not in the system dictionary, which means we don't have a definition of that. Now I'm going to try and do it. These are called the word address. And I think I'm supposed to be able to do this. Now, this is one of those things I was thinking was not working. Like this should put the address of this, or I maybe can say dot +8, saying give me the address of my current address +8. We'll try it this way and see. I mean, I'm curious if this works because it means I definitely misunderstood something we did. All right. So move load address x1 this. Okay, so that gives us the address, and I guess I got to loader that. X1 gets contents of X1. So, no, is that right? It's the push word address. No, I think that one's wrong. I want to make sure that we're pointing to the push word address when we get to that first word. The first word should be the address of push word, or the address of push word address. Do you need to specify that the address is held in a quad? Yeah, that would be a good check. Well, that's interesting, isn't it? Let's make sure. P2 of line 3 says it's definitely held in a quad. And this, the instructions don't have to be in, they need a 32-bit boundary, not a 64-bit boundary. Okay, so if it's 64-bit, they won't be hurting. But yeah, that's a good point. Because if this were one, we can't load a 64-bit entity on a mismatched boundary. It's got to be on a 64-bit boundary, I believe. Okay, I think that gives us our test. REPL test. Okay, so let me make from the top. Okay, so we're going to load secondary space pointing to L compile test space. So that's where we're going to write our secondary. We'll load the address of the number we want to interpret. We call compile. When it's done, the thing at L compile test space should be a pointer to the word address. So we get the address of compile test space, load the contents of that, and that should be the same as push word address. Okay, and then we check the second word. We again go back to L compile test space. We move forward by 8 bytes because we're after the second word, and we load the contents, and that should be 42. Okay, I think that's right. Now this should fail, no doubt about it. Okay, make, well, not quite that much. Oh, but that is the kind of thing, core post, core line 126, give or take. The post one is after post processing, so the line numbers are a little squeezed, but I'm pretty sure that, oh, maybe I have to say data. I got to look that up. I printed out that cheat sheet of stuff I did. But align data, maybe data. See if that's better. No. I don't know if I can do quad. Okay. Okay. Assert, is it equal? Man, I can't keep that straight. But push word address is the real thing. We defined it in core, but we didn't make it public. There. And then, oh, yeah, assert equals repl test. All right, good. 2 failures. It didn't blow up. Well, no, I tried just push and it didn't like it, so I needed to say quad. Relocation might work because it's read only. I don't know. We can try and let's see if we can dump the. It was the core file, right? Huh? Dump core. Yeah. We'll dump core and we'll look for that constant right around push. And hopefully it contains, well, I'm going to dump the core object file and then I'm going to dump the actual executable file we're running. And it should contain the right offset. So whatever the address of push is should show up there. Okay, so let's do that. So I think it's just obj dump, right? Minus D. Well, the D's the data area. We don't really need that. Let's dump core.o. Oh, maybe we do need it. Lots of zeros there. We've got some static memory area. Okay. Eval is not core. I don't think I'm on the right file yet. Yeah, it's got stuff that isn't ours. So this is more like the whole executable. Here we go. That's my error. All right. Huh. I would have thought I'd get an actual text section. All right, let's dump core tests dot out. More, and let's look for push. No. That's the text segment. This is the disadvantage of static allocation. At least while we're, maybe 500 would be a much better choice for now. let's just dump it without the more. And there's our prompts. Here's a big honking space, a bunch of zeros. You're right. Maybe I should just see what's going on. Wow, it's a lot of zeros. Okay, so that's data, text. I lost my assembly language dump. Oh, this is ridiculous. Okay, there's a bunch of data. Okay, yeah, I've been putting more realistic sizes in because we're getting more realistic work, but I don't know. I might learn as much just running it. Yeah, no tag. Okay, I'm missing parameters. History. Minus D. Oh, minus S. Oh, I did minus S. I'm sorry, I thought I did minus D. That's more like it. Okay, core tests. Let's just do core.o. Okay, there's push. Oh, I don't know. That almost sounds like he's not. It doesn't look like he put a real value there. ... That's kind of hard to tell. Okay. Yeah, I mean, I've definitely worked on systems like that. They just had the whole memory there. You just put whatever you want, and it's all allocated to you. But here, it keeps track of whether it gave you this address space or not. But I do have my sticky that tells me, hey, don't forget you can use mmap, which is what malloc and free use underneath. And we could dynamically allocate them, but I haven't yet. I don't know if I'm going to bother. You know, it's one of those things. I've got a lot of things I could do if I were, if this were a commercial product of equivalent scope, I would probably do stuff like that. You know, put it somewhere in a allocated block. But on the other hand, you know, if it just loads this, just whack the file into memory, it probably is fine with that. All right. Well, we have a very suspicious situation there. So let's, well, I guess we should just write some code. And then when we see it fail, we'll go wonder, like, is this really got that value in it? If it doesn't, I'm going to have to create a data area and write the address into the data area. That's our workaround so far. All right. So repl. Okay, so we're saying do the search. If the word is found, skip forward. Okay, I think I want to swap these around. So if the word is 0, it's really a not found. I'm going to reverse these blocks in a moment. Not found. So I should put this one up here, and this should come down. Okay, so if it's a 0, the word is not found, and we're going to go down here and do the error handling stuff. If it's not a 0, the word was found, and we're going to handle it. We're going to write the address that we get back into it. Word was found, store in secondary. Okay. Now, except I changed that. Well, let's change it. Let's make sure everything works with that one test. Yeah. Okay. I'll say compile, word not found. These labels are local to their file, but I'm sure I have another one somewhere, probably a new val. Okay. Okay, so I think that change was good. I almost want to just check that in that way. Let me do that. Let's, oh, I thought I had a way to turn these off. Well, okay, if I don't, I guess I'll comment out the code for a minute. Repl. Trying to be a little more focused on the smaller steps if I can. Oops, save. Okay, so I can commit that. Reverse order of test in compile. Branch for word not found. Okay, and then back here, and this test fails again. Good. Okay, and so in compile, if let's see, if the word's not found, now we're going to check for a number. All right, so x29, we're going to move x0 back to x29. We want to get our word back to our local area. So the word we're searching for, and now, I mean, this is very close to what we did in eval. That's there. We checked for numeric. Yeah, this is basically the same thing. Okay, so repl, oops, compile. I'll just paste this, but we're not doing exactly that. Okay, so do we want to check if it's a positive number? Okay, if it is 0, well, I think we need this address. Compile. Now it's word not found. But here, I think this is compile, let's say check for number. Oops. Okay, so unfortunately, string to positive consumes the word. Oh no, x0 is the word. Okay, yeah, so we're good. You've run str2 positive. It's not a 0, which means it is a number. So we have that number in x0 and we push it, and then we branch to exiting compile. Okay, that's half right. We also have to push a push. All right. So here we need to do a load address x1, and then the value we're looking is, yes, good catch. Load address x1, and that should be push word address, because that's the address we want to push in there. Data push. Oh, this is annoying. Trying to do this without destroying my x0 value there. It's not a data push anyway. Okay. X1 is push word address. All right. We want to store X1 at secondary space and then increment it. And then we want to store X0 at secondary space and increment it and exit. Okay, does that sound right? Yeah, it's not. It's right. Push word address and number to the secondary. Okay, so we load X1 because that's the number we're storing first, and then X0 already has the number. Okay, so this is push word address, and this is number. Okay, I think that's right. Whoa. Did I put the thing back? Where's the failing test? Compile, emits, push. Compile, emits, push. Okay. I mean, that's how it's supposed to work, but okay. All right, so now we can do make repl. All right, so last week, if you wanted to push 10 on the stack, you had to push 1 and then, duplicate it and add it and duplicate that and add this and duplicate that. Okay, I should be able to just put 10 on the stack. 10, 1, add, should give me 11. All right, that's good. Now if I make a word, I'll call it make 11. We'll make 12 just for fun. All right, and this is 10 to add. 10 plus 2 added that. Okay. Doesn't affect the stack. If I call make 12, I should get 12 on the stack. Boom. Okay. All right, we'll simplify. Get this to the easiest test case that shows it. Make 2 is 2 semicolon. 2. Oh, that worked, huh? Sorry, 10 to add. Is that not correct? Push 10 on the stack, push 2 on the stack, push 10 plus 2. So why did that one get in trouble? 10 to add semicolon. Make 12. Boom. Adding an L push to the same place as push. See if it works. Same place as push. Well, I mean, I think the L push. Well, no, that's right. This is the first time we're calling through that. Eval doesn't care. It's only this push thing. Okay, yeah. Well, no, having push word address global means we should be able to see it in the debugger. Okay, so, whoops, I guess I should choose what we're doing. LLDB repl.out. Where's the right place to stop? Well, we can stop and compile. We have to worry about colon, make 2, and 2. Oh, just run. See where it blows up. Colon, foo, 12, semicolon. No, wait a minute. That worked with 2. Okay, 12, 3, semicolon. Okay, we stopped at compile. Should do that. 2, 3. Oh, we're back here. Okay. And now when I execute foo. Oh, is that true? That would explain it, wouldn't it? Okay. Foo should blow up. All right. Bad access. Frame 0. Memory read failed. Where are we? Okay. All right. So I think you're right. If I run, yes, colon, make 2, 2, semicolon, make 2. Oops. Continue. Make 2, blow up. Okay. You're right. Yeah. Okay. So, I mean, I'm very suspicious that our compile is writing a 0 in instead of the real push address. So let's see if we can catch it on that. So I think break set minus b compile. I guess I am already. Let's do a new definition. Blue foo2 is 2 semicolon. I should compile for the colon. It should eat the foo2, and then it should call compile again for the 2, and then for the semicolon. Oops. Run. Oh, I'm already. Oh, I'm doing this on the wrong level. Okay, sorry. Run. Yes. Colon foo2 is 2 semicolon. All right. So this should be the word for colon. I'll continue. Do I not have a break? Let's let me quit. I think I'm just messing myself up here. Okay, break set minus b compile. All right, run. Colon foo2 is 2 semicolon. Okay, and then theoretically x0 is colon. Okay, so reg read x0, mem read minus b, minus c100. This should point to our whole input buffer with 0 bytes in there. Okay, so 2 colon. I guess I'm already. Can I say input buffer here? That'd be nice. Apparently not. Okay. Let's just do 70. Okay, yeah. So there's my colon, and then my register was 8B, 80, 88. Is this 8B? No. This is, oh, there's foo. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B is, oh, that's the colon. Okay. No, then 3B is FO. No. Where? Foo2. No, FOO2. Okay, there it is. Colon. FOO2 2 semicolon. Okay. New line. Okay. All right. And we're at 8B. We're in compile at 8B. 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. 32. That's the 2. Okay, so this is where we want to start stepping through, I guess. All right, so step. All right, yeah, so we should be, oh no. Okay, I'm in the dictionary routine. I'm just trying to get to the return. I don't know where I am. There's return. Okay. All right. No. I messed up. Sorry. Okay, so colon foo 2 is 2 semicolon. Okay, we're stopping at compile. All right. And I guess we can take a peek at this code. Compile. Prolog x29 gets SP plus 8. That's there. Move 29. BL dictionary search. This time I'll step over that. Okay, so step, step, step. Next. Okay, so now we have x0. It's not in the dictionary. Next. Okay, we skip forward. Step. Okay, now we're reloading the number string 2 back into x0. Okay, so let's read x0. Well, no. Let's look at x29. I guess we can get what we need from there. Okay, mem read minus C100. This should be a digit 2. Okay, it is. All right, so now we'll skip over string to positive. X0 should not be 0. It should be 2, yeah. Okay, so step equal, no, step. Okay, so now we got push word address into x1. All right, so step, read x1. Okay. All right, now let's do a mem read on this. Okay, so we're looking at the contents of that word address. 380, bunch of zeros. Okay, so that is not right. Now, can we do it in a data segment? That's a good question. Let's try it. Oh, I don't know why I tried data before. That's the way this works. And this is back to a text segment, which is code. And align 2 is our required thing there. We could probably do a P2 align, but it's okay. All right, so now we're saying, okay, it didn't work to have a relocatable number in the text section. Now we're going to try it in the data section. Is that what you were saying before? Relocation might work. Yeah, well, it doesn't seem to have worked in our text section. So let's try it again. Now that compiles. It passes. So, well, we're checking the contents. All right, our test makes sure we get the push word address. Well, that is what we get. But it was our duty to set it up right in the compile case. So we'll find out if we have this time. All right, so make repl colon foo is 2 semicolon foo is 2. Okay, this is going better. Foo 3, 2, add, semicolon, foo is 5. Okay, pop should be, well, add should be 7. Yeah. Okay, I guess that's what it is. It's okay in the data segment, but it's not okay in the text segment. That's really odd. But woohoo, yeah. We got numbers going. Okay. That's, well, I mean, I had this vision of our initial dictionary would just be like, define it in the text segment, it's read only, who cares, and go. But the assembler is just not clever enough to relocate those numbers, those addresses, which is weird because it does relocate those addresses when they're like targets of function calls or their branches or things like that. It knows what to do. So I don't know. You know, it's just, I think it's just comes to they don't really want to support their assembler any more than they have to. You know, like I've said, I've used, I mean, even like the PDP-11 assembler, I mean, is, you know, I don't know what year that came out. PDP-11s were pretty old. You know, but certainly in the 1980s, the PDP-11 assembler was far more sophisticated than this one on some of these things, you know, for better or worse. You had like a whole, what do they call those? Overlays. So you could allocate a section of memory and say, first time through, I want you to take the A block of code and copy it in. And if I say switch segments, I'm going to copy in the B block. And, you know, so A and B you would have to make sure they never called on each other, and anybody from A could never call B or vice versa. But you'd be able to load in that stuff at different times and save a lot of memory. And you only had I don't know what they were, 64K machine by default or something. They did put in stuff later, but, you know, the natural size anyway was 16-bit. Yeah, because they're in different sections. Maybe it is just that, but this assembler also only supports data and text. It doesn't let you create other named segments, which again, even the GNU assembler they seem to have derived from let you do that. You could create a segment that was, you know, text ABC segment and text DEF segment and put some stuff in ABC and then other in DEF. And that's really handy if you're trying to kind of coordinate where things are going in multiple things at the same time. So in the macros, it would have been nice to be able to do that kind of stuff. But yeah, I mean, it works. So this is good. So compiling numbers writes a push and the number. Yay. Okay. I don't know. Did I not? Message is a little off. Okay. Well, that feels good. So let's go down here. Numeric constants compile. Okay. What did I call this today? Compile numbers. Okay, so we are doing this. All right, not even too far in the day. Call error handler macro. Well, the other thing is we need a word for 0. Okay. And that might be, I think just to kind of get the compiling numbers thing kind of fully functional to you, we should have that word 0. And then somewhere in here, I've got a README. I have updated this kind of offline, but I've added in stuff as you go. So I don't know, I guess maybe we'll put those in the arithmetic section. Load 0 or push 0 on data stack. 1 is push 1 on data stack. I don't know how to line those up anyway. Okay. And let's do that. Now, I guess that was in core. Maybe. Oh, we had push 1. I think we'd like a push 0 by the same analogy, and let's write a test for that. Yeah, we didn't test our 1, but let's test our 0. BL push 0. Put that more down with our semicolon stuff or adds. Okay. Yeah. Okay, so I think this is just testing the routine. Push 0. So all right. So if you, well, we have to have a data stack somewhere. L push test stack. I think that's the one we allocated up here for that. Yeah, that's fine. Okay, so we want our data stack, which I don't remember what the name is. Oh yeah, VSP. VSP. VSP gets this. And I think we'll explicitly write something in there. So load or store register VS. Well, let's store a pound 37 in VSP where VSP points. Okay. So I'm just making sure we have non-zero in there first. And then if I call push 0, and then at the end, then I should be able to say the contents of the push stack should be 0. Load address, let's x0, load x0 with the contents of x0. And load x1, move x1 gets 0. And then BL assert equal. Okay, so the contents of our cell should be 0. L push stack, but also the VSP should be push test stack plus 8. Okay, so if I load this, add x0 plus 8. Well, I probably should move x0 gets the virtual stack pointer, x1 gets this address plus 8, and again they should be equal. Okay, so start VSP correctly, shove garbage in VSP, push 0, look at what got stored at VSP. It should be 0 now, and the VSP pointer should have moved forward by 8. Yeah, so we've initialized it with this. Okay, and this should fail. Well, I'll tell you what, let's store VSP because we know that's not 0 in here. Okay, and now we'll see what VSP was. All right, no push 0, good. Core. Oh, global. I saw a fail in there. Okay, right. So it comes up as something 56, and at the end we expect it to be increased by 8, but it was not. So yeah, unfortunately, need a register to store. But that's okay. All right. Well, this should be pretty simple. If I can find it again. Okay. So I think we can just say data push XER. So that's the value we want in there and return. Okay. Make sure that test actually is running somewhere. Push 0, pass, pass. Okay, good. This is what I want adding the new ones to be like. You know, write a test, boom, make it pass. All right, HTTP, add a word for 0. All right. Okay. Now, call error handler macro. Well, this is sort of, we use this error handling stuff in 2 places. So like, should we make a macro for it? I don't know. Here's repl. It's this that you have to load the handler and then execute it indirectly. X0 is X29. That's the string we're putting out in the message. Word not found this. I guess that would be an okay macro. Now repl. Let's see what we have for macro files. I thought we put one out for repl. Yeah, we did. Okay. Call word not found. I don't know. Maybe this is enough. Well, that was the code. X1. Global word not found. And then the call site looks like this. Yeah, maybe that would be better if we just let's see if we can do that with the macro thing. I don't know if it will or not. Oh, well, I guess we could move this in here too. X0 gets pointer to word. If that works. Okay, so word not found, call global error routine. Input register with pointer to word uses x0, x1. Okay. And then repl theoretically we don't need this either because we did the move 0 inside. Okay. This should pass, whether that's oh, stupid thing. Oh, I didn't do a backslash. Okay, it's on me. Then if this doesn't work, then it's not me. Okay. All right. Well, let's just run make repl. We did test that, but foo. We're not found foo. Okay. That was build. Let's do compile. Bar is foo, semicolon. We're not found foo. Okay. And then if I call it, it's still not found. And if I call bar, he's probably not found. Doesn't do anything. Okay. That seems good. Let's do it in repl. I guess I'm going to look for uses of that. Okay, so this, I should be able to do the same thing here, which is word not found, and then register 28. That. Okay. Main, that's the setup. That's our definition. Yeah, that's okay. That's fine. It's replacing the pointer so it can test it. Good. Okay. And then that's repl and compile. Or core tests. Okay. Compile. Writes message if not found. Eval calls syntax error for unwrote. Okay, fine. So, okay. Okay, and then I think I want to make it, you had a good suggestion the other day. Those word not founds, it'd be nice if they printed in red. So let's do that. Print error message in red. Okay. And I'm just going to make this a visual test. Let's find our AS unit. Okay, so failed. Yeah, we've clearly been here before. Okay, and then the global word not found handler. Oh, we want the one in main. Word not found error. Now, isn't this weird? Oh, no, it isn't a data segment. Okay, okay. Because that worked for us before. That was the one that worked. So I think we're refining that rule now. I think we can say it seems like relocatable addresses work when they're going from the data segment to the text segment, pointing to things in the text segment. Relocatable words work in the text segment for branches and procedure calls, but they don't work for just plain old data. All right, it's a consistent rule anyway, if it's not a great one. All right, I call this enter red mode, and that probably should just be a local. I'm not as consistent as I want on these. Escape 0M. Okay. We're out of the old VT100, maybe even older. Okay. Repl. I guess it won't hurt to be explicit here. Printing is not a high performance area. All right, and we'll run. There we go. Okay, yeah. I think it's in our character, if not completely charming. Okay. A little more attention to it anyway. Okay. Well, that is done. Okay, so now, how are we in time? 3:11. Okay, so my anticipation for the rest of this week, I mean, at least until we get it done, is just working on primaries. So we have plus, minus, and times. We don't have slash, mod, etc. We don't have any of the logicals or relationals or whatever. Maybe we have one, but that's okay. So we don't need push at this point. I haven't worked out memory stuff at all. Move that down with strings because I also haven't worked them out. You know, I would like to get this print one in place first. I think that gets us more in the spirit of fourth doing stuff. Okay, so we have NL. Let's find main again. I lost it. Well, let's close. Let's close to the right. All right, main. Yeah, we have NL. I guess we should. Oh, we don't have 0 yet. We're not found. Yeah, so let's get that added in. Is push 0. And I'm not going to test the existence of this dictionary being what it should be because I think I just don't tend to do those tests of lists that lists are the contents because I end up copying and pasting or you know, it is what it is. Visually inspect this and you got it. Okay. All All right, so those are the words we have. Let's see what README says for print. Okay, this is really not print. It's dot is the traditional 1/4 anyway. Let's do that. Now we have some sort of print already. Let's see. Find print. Is that C-like? Yeah. Okay. So print address of we have print num actually. X0 is a number you want to print. Well, that's not quite right. Yeah, because X0 really we want to print the thing on the top of the stack. Now I don't know. Let me see. Is print a destructive operation in fourth? I don't remember. I think it might be, but it would be kind of handy if it weren't sometimes. Got my fourth book here. Maybe not the best reference. Yeah, it doesn't bother to say. Maybe I should look up that one that's online. This threaded interpreter book, it's like I want to go through and edit for the guy. It's a lot of passive voice and it just sort of bounces around back and forth sometimes, but it's been a good trigger for me. Okay. Oh, keyword pops the top stack entry dot converts to characters and displays the result followed by space. Okay, I don't know about the space bit, but we would like something that's like this, but it works on the top of the stack. So it's not really the C-like function itself. I guess I would call it core, although I think our core is getting a little too big. Maybe this should be my starting step to start defining each one in its own file. I think that might actually make better sense in the long run. Because otherwise we have, I don't know, do I want to have 45 files or 45 keywords? Now maybe I should do them by cluster, like maybe IO. Okay. Yeah, maybe that's the way to do it. So we would pull out stack and IO and stuff like that. All right, let's do that. Now, what do I want? Well, I'm gonna manually test this one because it's IO. All right, but let's make it okay. IO, put it in core, but the next level up. All right. And this is, how can we tell it's a string or a number? Yeah, I think I'm gonna make strings pay the price. And so I think I'll borrow the old basic convention and use $sign for string. So I think we'll have a $. It might, yeah, you could make a case for $pound and $, make them all specify, but I think I'll just make the strings pay for it. But we do need to distinguish because we're just gonna have a number saying there, is it a pointer to a bunch of strings, a bunch of characters, or is it a pointer, is it a numeric value? Okay, so I guess this is just the dot print maybe. All right, and we're gonna need some stuff. Where's our core? Core and that for sure. There. Okay. And, well, his job is, okay, he's in the text segment. He's aligned to a 2-word boundary or half-word boundary. We want him to get a value. I think we have assembler macro. Data pop to register. Yeah, that's what we want. X0. We're going to be able to print num. Now, the default prints a space after the number in fourth. I don't know if that's a good idea or not. Maybe we should. All right, let's give ourselves a little data to do that with. Data.p to align. Well, actually, it doesn't care in this case. Let's put a space. I think our print, where do we have it? See, like print num, and then prints a string. Okay. I think that's pretty good. And then main, we should define dot is dot print. Okay. And make repl. Yeah. Undefined symbol for architecture 64. Dot print referenced in main.o. Dot print is a global. Oh, we don't, our makefile. Core, I guess this is IO. Core dot defines and assembler dot macros. Where's my repl dot out depends on dot o. Let me see. I think it just said it was a space after the number, but we can Try one of the others. Pops the, yeah, followed by a space, at least according to these guys. All right, that depends on that. Maybe that'll work better. No. Print num is referenced from dot print. Okay. Oh, it's lowercase. Okay. If I say 10 dot, it should print a 10 space and then show me my stack with a 0 on it again. Not quite sure that's acceptable or not. I guess in regular fourth, that probably is what it would do, because they would keep going. I find it a little weird. But what it does do is, well, let's print a new line. Okay, now why are you not? Something's funny. Yeah, something's weird. Okay, so if I do 10 dot, should print the 10 and then pop the stack. But he's not. I don't think he's waiting for input either, because he's not saying word not found. What could be going on? Did I not? Okay, I popped the data stack. I printed the space. Yeah, I'm definitely confused, because I would have thought, I mean, what I expected to happen was dot would do 10 space, and then I thought it would go back into at R10 and look for more prompting. What? And yet it doesn't seem to be waiting for this input, but it doesn't seem to be terminating either. Let's 33 dot. Okay, what about a semicolon? How about a control D, end of input? No, it's weird. Okay. Let's look at add. Oh, I didn't do my... How many times am I going to burn myself with this? Standard prologue. Because I called a routine. You'd think I'd be good at spotting the mistake at runtime by now. Okay. Dot. Top of stack is weird. Yeah. That is true. Printing to stored LR. Well, I mean, I think the definition of dot is that it does pop it off, but I went in here now and I popped off an empty stack, so that's not very smart of me. 10, 20 dot should print the 20 and then leave me at a 10. Okay, yeah, that's closer to what I would expect. I guess I should have expected the top of stack thing to come out before the print. And really, all our did I pop the value when I printed it? Yes. So top of stack was 20. I hit dot. It does 20, and then it says now the top of the stack is 10 again. But this top of stack is this. I don't think that should be in our main loop anymore. We've we did it before because we had no mechanism to see what was on the stack. Now we do. So I'm going to take that off of out of the REPL. It is a little bad that I'm letting you pop an empty stack, and maybe we should enforce something there, but I'm not. Yeah, you have to do a dupe if you want to print something just to peek at it. Yeah, I mean, it's the end of stack is a warning we don't issue, so I'm gonna live with that. But I think what we've done though is make dot pop top of stack and print it. Okay, and I think that's a good thing. It kind of tightens up that loop a little bit. All right, so let's go to README. Make sure I'm saying that's what that does. Print number, print pop, and print number on top of stack. Oh, it is destructive. Yeah. Okay. So I was guessing before. Good. But, well, okay. This is IO. Make dot pop and print a number. Okay. But I also want to remove print, automatic print. Automatic print from REPL. Okay, so that's the thing I really want to do first. REPL. And again, that was something we put in, but I don't think our REPL does not really print. No print, use dot if you want it. So it's not really a REPL, I guess. It's a rel. All right, prefix, suffix, print. Okay, so where's prefix and suffix? Yeah, this stuff goes away. Okay, that's what I expect at this point. You could get intermediate results. Dot 7. Oops. Is it add? Sorry, I'm distracted again. It is. Oh, we should make that operators. Okay. But I can do 2, 3, add, dot, see the intermediate result, 7 mul, and I should get 35 on the stack and print it. So it should print two things. Dot. Well, 6. Let me start that again. 2, 3, add, dot, 7, mul, dot. 2, 3, add. That should push 5 on. Oh, like you said. Ugh. Okay. 2, 3, add, dupe, dot, 7, mul, dot. Yeah. Okay. A little weird. Yeah. Okay. Well, make repl no longer automatically print. Good. Okay, I think it's a good time for a break. We've made some good progress though. All right, we'll take a 3 or 4 minute break and come back and tackle the next set of words. Actually, I'll probably switch over to real operators for those, make them a little more easy to read. All right, see you in 3 or 4 minutes. All right, welcome back. Okay, let's go on to arithmetic. Well, let's first get these plus, times, subtract, get some normal operators here. I guess we'll just pull these together. Okay. Plus, minus, times. Okay. All right. And those renames don't affect anything. That's all just at the REPL level. It's not, our tests don't depend on those names. Okay, so core, let's extract an arithmetic. We'll need these two again for sure. Excuse me. All right, and let's find them. Global add submul. Oh, screwed that up again. Oh, man. Okay. Okay. Let's go find those. Duplicate. Okay, there's that. All right, now this should have all been neutral. Add reference from start. Oh, I didn't add the file and make file. And then REPL tests. I think we need arithmetic tests as well. Could I include the arithmetic into file? Yeah, you could. I don't. I don't know. I think it's nice to have them broken out a little bit. But yeah, I wouldn't say it's wrong to do it the other way or anything. No rule to make arithmetic tests. Arithmetic test.o depends on arithmetic test.s. Arithmetic test.s needed by arithmetic test. Oh, we don't have an arithmetic tests. Okay, that's the problem. All right, so core tests, I'm going to split. Not macro tests. Darn it. It's just too automatic. I guess it's a little weird of me to not do it that way, but it just seemed like it was too much, like I was better off if it was flat. Okay, so now I have everything, but I'm going to take out anything that's not arithmetic. And then over in core tests, I'm going to take out anything that is arithmetic. Well, I'm going to call that a stack one. Okay. Yeah, as long as the core file feels, the core test feels even longer. So I think it's worth splitting it up. Tenths. There has to be a way specified. Yeah, I don't know. All right. Let's try again. Make L data. L push test stack. Okay, that's a little more. Let's find. Declaration for that. 11 test, I'll push test stick. Okay, this one is not in here. Make sure I didn't delete it from here, though. Push 0. Okay. I think I'm getting there. Okay, address. L data. Oh, he was, L data was in a text segment, or yeah, text segment. Okay, is that all it was? If it's in a text segment, it has to be prepared to do fix-ups and stuff that it doesn't have to the other way. Okay, which one's complaining? Load -o arithmetic test dot out. Oh, well, he doesn't include arithmetic in his list. Okay, where's makefile? Add mul and sub depends on a. Wait, LD. -o arithmetic test dot out depends on arithmetic tests. Oh, right. Wrong place. Now, why just 2 out of 3? -o dictionary test that out. I guess he should depend on arithmetic, yeah. Dictionary tests. Interpreter test, same thing. Repl out depends on that. Okay, I think we're getting there. All right, we should see some arithmetic tests up at the top. Arithmetic test dot out. Well, oh, they say core tests. Okay, good. That I can fix. Losing my. There they are. Okay. All right. Let's pull add sub mul to arithmetic.s and fix dependencies. All right. Now we're ready to go on. Arithmetic tests Well, the next one is divide. B by A is dividend. Is that the right word for the result of a division? Now, I think these are looking pretty darn similar. Is that correct? They're not quite the same. VR. I guess they're not really quite the same. Well, let's take the whole thing as a starting point. Okay. VSP gets the contents address of test stack. ADR VPC L data. Okay, I guess that's L data. I don't really think, is that VPC really the thing to use? Well, he's got L data plus 8. Let's see what those are. 142.58. So subtract is 84. Multiply is a nice big number. Okay, I guess I should do divide. Well, 142 divided by 58 is 116, but 3 is 150 something, 170 something. Okay, so it should just be 2. Div. We expect a 2 because it's integer division. Yeah, that's why I'm wondering. I don't think it should care. But I don't know what's ADR. Is that add? Literal. I guess it's like address. Relative. Okay. So that is kind of a load, a move. But push, I thought push would want x0. Push is in core. Push the following word on the stack. Oh, it does VPC. Okay, because well, yeah, push is a runtime entity, and because it's relying on where it is in the secondary, it's using the VPC. Okay, it kind of makes sense. Hey, Ricardo, game dev, nice to see you back. So we're working on an assembly language version it's for ARM64 of a language interpreter, and the language is sort of like Forth, which is a kind of a stack-based language popular in the 70s, maybe 70s into 80s, I guess. And we've got the interpreter running and we've got the compiler working, and we're just filling out the primary. So all the words like plus, minus, times, divide, greater than equal, and, or, not, all that stuff. We don't have any of those words. Our compiler is very minimal, so it's good at defining new procedures. Reminder to come here since they're doing hex. Oh, well, yeah. Yeah, I'm not sure if that's good or bad, but you're welcome. Good to see you. Okay, so let me clear these, or I guess we just have to go off this window. All right, so I think we have our test in place, but we don't have a routine for div. So we need to at least stub it out. Arithmetic, okay, div, and just return. And we should see arithmetic tests failing. Well, okay, global. Just stop with this one. Okay. Oh, thank you. All right. So it failed. It got 58 instead of 2. And 58 is the second number we pushed. So it just didn't do anything. All right. So, well, I don't know how to divide on this processor. Division is a little funny because, you know, your results, I don't know. Sometimes they put it across 2 registers, or who knows. I think like page 300 is where we start actual stuff. FDiv. SDiv is, what's that? Okay. Compute the division. The remainder can be computed using msub. Okay, good to know. If the signed integer is performed, where int is the most negative register overflows, okay. Division in 0, but it results in 0 being written. Yeah, okay. Oh, we got signed div and unsigned div. Okay, and let's go look at sdiv. Sdiv, xd, xn, xm. Okay, that's pretty simple. All right, so I think we're just going to do kind of this stuff. I mean, it's all sort of the same. All right, so we'll pop the top 2 things on the stack. We'll do an assign div x0 equals x0 divided by x1. And we'll push x0. Okay. Yeah, I guess I got to make. And then it should be in here. Arithmetic tests. Div is div. Okay. And let's add that to our main. Whoops. Okay. And I guess we'll just run the REPL just to see it live. 7 divided by 2 should be 3. Dot 3. Okay. All right. Make, sorry, ACP add support / Okay. Good. To do. Oh, we did that. All right, arithmetic. We did /. Okay, so I'll take these out. I'm thinking this is really %, and this is /% for div mod. Okay. So the yeah, Nick or not. I want to stick to the sort of binary ones first, because I think there's a macro waiting for this stuff. Because notice their pattern, right? It's all that data pop AB, do something binary, data push, data pop AB, do something binary, push, and so on. Now we need to do more. I don't know. Maybe this is clear enough as it is. It's already a macro. Let me get a little documentation on div. Okay. Yeah. So I think mod, they told us what we had to do. It's a little different. Okay. Well, I'll leave it sdiv for now. I'll leave it wrong. All right, but we have another test coming. Okay. Mod B by A. If you push 7-3, is it? Am I doing it backwards? Oh, B's the second on the thing. Okay. Mod B by A. That's right. Okay, so we're going to load these things. We got this. Now we got 142 mod 58. Okay, so twice is 116. 42 minus 16, is that 36? 46, 52. Yeah, 36. Okay, so I expect mod to be 36. Yeah, I'm not sure it makes sense. You'd probably have to do like a start macro and an end macro. And it's like, that's kind of annoying. And especially when it's a one-liner is all you're replacing. So I'm not sure you get any leverage on the arithmetic side. Okay, so there's mod here. We need a global for it. Okay, and then I need to make sure the test includes it. Now maybe the test deserves the macro. B by A is dividend. Okay. Yeah, I can make a better case for that, I think. All right, so that should be a failing test. Right. Okay. We get expected 36. We got 2. Okay. Let's do arithmetic. Okay. And then I'll put this in too. To replace top AB with B mod A. All right, now where were we here? sdiv. Was it here? divide where did we see that? The remainder computed is numerator minus quotient times denominator using M sub. Well, numerator minus quotient times denominator. Okay, so sorry. Quotient is going to be in x0. All right. And then if we do M sub, I think we want, well, let's go find, it's numerator minus quotient times denominator. Okay, so numerator is our A. So we don't want to destroy x0. Let's do x2. Yeah, it's got the wrong operation in there. Okay, so if I take x2 equals x2 divided by x1 and then M sub, well, I think it's going to be x numerator denominator. Numerator's the top, right? Okay, so we're dividing by let's change this. X2 equals x0 divided by x1. So the x0 is the numerator. X2 is the quotient. And x1 is the denominator. Okay, well, we'll look up M sub and make sure that's right. Okay, M sub. XD equals XN is the multiplicand. D is the destination. XN is the multiplicand. XM is the multiplier. And XA is the minuend. So we're subtracting I don't know. It seems like it does. So, okay, it's got 4 registers. So the result is x0. It wants the two things you're multiplying next. And then it's subtracting the other. What's a minuend? Is that the thing it's subtracting from, or is that the one it's subtracting to? From which another quantity, subtrahend, is subtracted. So the minuend is the left-hand side of the subtraction. Okay, so it's a weird order, but it's legit. Okay, so we want x0 to be x2. X2 is the result of the division. Well, I guess it's really kind of like x1 to be more accurate to the thing. x1, x2, x0 Is there a small? So I think this is, well, it's going to multiply the first two and subtract them from the, sorry, it's going to multiply these two, the middle two, and subtract them from the end number, if I'm understanding correctly. In our case, the end number is the original numerator. So numerator minus we'll find out. I think I read it right. Make arith. I did not. Okay, we're getting 26, not 36. Yeah, it sure does, doesn't it? Let's read it again. M sub xd is destination. Xn is the multiplicand. Xm is the multiplier. And xm is the minuend, which we decided was the left-hand side of a subtraction. So it seems like it's minuend minus xn times xm. So minuend is x0 is b. So the b is the value we're taking the mod of. X0 is the minuend. X1 is the divisor. Huh. All right. I know. I agree. It sounds goofy. M sub. Well, it's multiply and subtract, but it seems like it would subtract. So what is 26, right? X1 is, sorry, X2 is our remainder, which we know is 2. 36, right? No. Well, this is mod for one thing. All right. What am I getting wrong? I said it should be 36. They're saying it should be 26. Let's check my math before we go too far. 142. So 2 times 58 is 116. Subtract that from 142. Oh, that does sound like 26, doesn't it? 26 and 16 is 3642. Okay. All right. Have a nice night, Ricardo. Yeah, I think it's just my math. 36 is not the right answer. 116 plus 36 is 146 plus a little extra. So, okay, it is 26. I guess I give the instruction more credit than I should. I mean, it looks goofy, but I mean, they use the word minuend very carefully. So, I'm gonna assume that's okay. All right, but I do think, like these tests, I don't know, one of them was different, but I bet it could be made the same. Yeah, okay. We're pushing the same value twice here. Let's make this test like this one. So between the two pushes, we're going to increment. And if you add, I don't know where the 200 came from. ADR VPC L data push, ADR VPC L data plus 8 push. Okay, put this as close as I can. All right, I would have thought, I don't know where 142. How did this work before? Let's see if this works now. Oh, well, this should pass. Except, yeah. Except I screwed up something in the other. Well, no. Dot arith. Okay. It was a different way of getting there, I guess. Because before it didn't have this, so how did that get moved forward? But I don't know. Okay, but I think they're the same now, right? So I think you could make a macro binary op test. And int him. Okay. And test start test name. And VSP, we're going to do all these operations on that thing. Okay, BL push, BL, and then routine to test, and then expected. Okay. And so if I did bin op test, add stuff, I'll get a better name in a moment. Testing add with 200, that should do the same thing as what we have. Except it doesn't. Oh, because we got to put this in. See, this is where it'd be nice to have two different text segments, and then I could keep the main routine in one and add stuff to it in my macro, and then add stuff to the other text segment with the actual contents outside the endim. Ooh, that's a good point. Two problems. If you got two, you probably got more than that. All right. But we should see make, and then we should see add stuff. Okay. So yeah, I think that's gonna be nice. Let's rework these. Add a plus a. Let's take this one off because I'm gonna get rid of him. All right, so that was the A test. I'll put them all in and then I'll make sure. Oh no, I guess I'll take them out as I go. Now, not everything will work this way, but a lot of it will. A minus B was... well, he's not really recursive, but he does call other macros within himself, right? We don't call bin op and bin op, but we are calling a different macro, which we've done before, right? Load address is a macro as well as that. Okay, subtraction, the difference is 84. That was 84. Product is 8236. Div is 2. And the last one's mod. And the value was 26. Okay, would have been better to make this before we did these last few, but I'll get there. Okay, now this should still pass. All right. So we've added mod, and let's add that to main. Put it over here somewhere. Main. And this one's a percent. And mod. Make repl. What do we got? 7 mod 3 is 1, right? 6 from 7. Oh. 3% dot should be 1. Yes. Okay, I'm sorry. What did you think didn't work? You definitely can call macros in macros. You got to be careful. I mean, you can get yourself in trouble, but they're not really recursive, right? Because I'm not calling binop inside binop, or I'm not calling test start inside test start, but I am, so it's nested but not recursive. It's sort of like regular expressions versus parenthesized expressions. You know, you can't express parentheses, balance parentheses with regular expression. Okay, but that is looking good. Okay, add percent, which is mod operator. Okay, now the next one's different. So div mod, let's see. We did that. Div mod gives you 2 answers, so it's a little different than your typical arithmetic one, because usually you get 1 answer from an arithmetic expression. Yeah, so, yeah, I see what you're saying. Yeah, because I accidentally left it inside. I don't know. I would have thought it would complain, honestly. Or run forever, I guess. On expanding it, you know. So I don't know what it expanded it to. That would be interesting. But I don't think you can make recursive ones with this. There are assemblers out there that do allow it, but not this one. I mean, you have to have an if statement of some sort, assembly time if statement, and assembly time subtraction or shrinking a string or something to let you get order. Yeah, that's a really good question. I think you should push the div then the mod would be my guess, but I don't know. And I think I took this from here, but I don't think they don't tell there. It's like, that's what I was saying. This book's it's good, but it's got its flaws. And one of them is the index is not very complete. Memory reference, arithmetic. Okay, they have a slash, they call it slash mod. But I think div, slash percent. So the second stack divided by the top returns the quotient as the second stack entry and the remainder as the top entry. Okay, so it does return the mod first, which I think it's the best order, because when you're using remainder stuff, right, you're doing something and then you want to do something with the remainder. Is that right? I don't know. You could probably find either use case, but their traditional way, I mean, was slash mod. So slash was on the bottom and mod was on the top. We just had to be consistent with ourselves, which is tough enough. Okay, core. Let's see. Oh, we're out of time. We'll pick up there tomorrow then. The difference will be that the div mod doesn't fit our binary test because it only tests the final result, and we'll need to pop a second number off the stack and do that. We could probably find another way to do it, but I think that'll be okay. A little different. Min max are they're back to binary, but abs and neg are unary, so they're going to have their own thing. All right. Well, I think we're on track. We got several things done today, compiler wise. Finished up the numbers, got the 0, got the word not found improved. We took the pop out and made our own print. It's a dot. We got a couple new operators working. I think we'll knock through these arithmetic operators tomorrow, move on to the logicals, and just keep going down the list. These are the hard ones. I'd like to at least get to those this week, even if we had to shortchange some of these others. But I think, again, like swap keeps the same two things on the stack. Or I should say, pop, you look at the top thing on the stack. Swap, you look at the top two. Dupe, you look at the top one, maybe. These two, you look at the top three. We might get a little bit of a macro, get through those kind of quickly. All right. But yeah, it's a good one. Relational before control. Yeah, that's a good point. I mean, they're all kind of, if we had real users at this point, we could talk to them about what they needed first, but they would need relational to write loops, and you could, until we have loops, you don't really have everything you need, or if else for that matter. But yeah, we're getting there. I think we'll knock through a bunch of the stuff tomorrow, and then hopefully Wednesday or Thursday at the latest. Like first thing Thursday, I'll definitely start control stuff, because that's, they're more similar to, their meta words, like they have to run at compile time, not at runtime. They generate other words that run at runtime, kind of like we did with push. We generated that word. They're gonna do the same thing. We've already defined the words they generate, the jump and the conditional jump, but making the control word that does it will be the challenge. All right. Well, thanks for joining today. I'll see you tomorrow, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC, and have a good evening. Take care. Thanks again. Bye-bye.